Now, I give you a coin and I toss it 5 times and I get 5 heads. What do you think is the probability of heads of this coin? I give you a 1 rupee coin. Now Jay asks, according to this, no, let's be intuitive. AI is a lot about intuition and insight, and then modeling it mathematically. So I toss this coin, I show you the coin, it's a 1 rupee coin, I toss it 5 times, I get 5 heads. How many of you think that probability of heads of this coin is 1? How many of you think probability of heads of this coin is 0.5? At least some hands have been raised. Other people are not listening or don't care? Let's again ask this question. How many of you think the probability of heads is 1? How many of you think the probability of heads is 0.5? Okay, for other people, how many of you think the probability of heads is somewhere between 0.5 and 1? Many people. Wow, all right, very interesting. How many of you think it is closer to 0.5 than to 1? How many of you think it is closer to 1 than to 0.5? Wow, that is a split, first time. Some people really believe that a 1 rupee coin where you can see both the sides and you are just MS Dhoni and always gets the right answer, the probability of heads is closer to 1. So, okay. Well, I would have differed with the people who raised the hand the last. I understand that the probability of heads you might think is between 0.5 and 1. But years of understanding of tossing coins have told us that it is usually very close to 0.5, if not exactly 0.5. And if you get 5 data points which have just heads, that will not move you so much that you move towards 1, right. I would have said that the probability is probably 0.5, if not slightly more than 0.5, but 5 data points is too small a number for me to make a strong claim that the probability of heads is 1. Okay? And if I had done this, why would I do this? What am I saying? What is the intuition that I am capturing? Exactly. What's your name? Ash. Ash says that generally coins have probability 0.5. That is the intuition I am capturing. However, in maximum likelihood estimation, if I did this, my probability will end up being 1, and if I did smoothing, it will end up being 6/7, which is a fairly high number. So, in some sense, maximum likelihood estimation is saying each parameter is equally likely. All parameters are equally likely. I have no preference for one parameter versus another parameter. But in the case of this coin example, what I am trying to say is that the parameter which is close to 0.5 is much more likely than the parameter which is close to 1. Now, let me flip this on the side. I toss this coin 1,000,000 times and I get 1,000,000 heads. Now, how many of you think that the probability is 1? Come on, not a hard question. I toss this coin 1,000,000 times. I can do this, right? And I got heads 1,000,000 times. What is the probability that the coin of heads is 1? It is very close to 1 or very close to 0.5? Very close to 1. It is the Amitabh Bachchan's coin in Sholay. Just saying, I do not know, you are too young to even know Sholay or not, we do not know, right. So, a priori, I would assume that the probability is 0.5. If I give you no data whatsoever, I am going to assume probability is 0.5, because I know that coins have probability 0.5. You give me 1 data point, it does not change me by much. You give me 5 data points, it does not change me by much. You give me 1,000,000 data points, obviously I change. But unfortunately, maximum likelihood estimation will not have that characteristic. So, therefore, the reason maximum likelihood estimation does not have this characteristic is maximum likelihood estimation says all parameters are equally likely 0.5, 1, 0, 0.9, 0.3 all parameters are equally likely, whereas I know that the parameter close to 0.5 is much more likely than the parameter that is close to 0 or 1. And in order to model this, we use what is called the MAP learning. MAP stands for maximum a posteriori learning. In other words, it is something that uses Bayes rule. That is why there is a posterior in it. So, if there is a posterior, there has to be a prior, and the prior is on the parameter here. So, I am saying that instead of optimizing probability of d given theta, I am going to optimize probability of theta given d. I want to find such parameters which has the highest probability given the data that I have seen. But I can always use Bayes rule. So, when I use Bayes rule, I will get argmax probability of d given theta, which is the maximum likelihood objective function, times probability of theta, and this probability of theta is our prior on which parameter we prefer and which parameter we do not prefer. And here I will say that probability close to 0.5 is a parameter I will prefer and probability close to 1 is a parameter I will not prefer. It allows the user to input additional domain knowledge about which parameters are more likely and which parameters are less likely. This leads to much better parameters when the data is sparse. If I toss the coin only 5 times, maximum likelihood would shift it very close to 1, maximum a posteriori will keep it very close to 0.5. Of course, it reduces to maximum likelihood, parameter stops to have its weight once I get a large amount of data, because then prior has very little meaning and it is all the likelihood that is sort of overpowering the objective function. So, in the limit of infinite data, MAP tends to ML. Okay. Okay. So, now and again I am not getting into the details, but if you want to estimate this, you will take probability of theta given d, write down the mathematical expression and then using Bayes rule and then take the derivative with respect to theta to get the best parameters. There is a lot of stuff that I am hiding under the rug, like how do I even mention probability of theta, how do I represent it, because theta is a continuous parameter. So, then you have to represent it using some other distribution, family of distributions like a beta function, which is a probability distribution between 0 and 1 for example, right, but I am not getting into that. Now, this is called the MAP learning.